Okay, now we've got a theorem called the extreme value theorem. So the extreme value theorem says if f of x is continuous on a closed interval, then f of x attains an absolute maximum value m, so we call absolute maximum big M, and an absolute minimum value little m on a to b. So it just means if we restrict a continuous function to a closed interval, so both endpoints will be there, then on that interval, on that little piece we're looking, we'll have some biggest value and some smallest value. Just means on a closed interval you can't have, if you're continuous, you can't have it going up to infinity or negative infinity. Okay, now we're going to learn about one way that we can at least find local maximums or local mins. So this is called the first derivative theorem for local extreme values. If f of x has a local maximum or a local minimum at a point C in the domain of f of x, then f of prime of x is defined at C and f prime of C is 0. Okay, so let's talk about what that means. So if we have a local max, which is like the top of a hill, or a local min, okay, then we have what we're saying is the derivative, which remember the derivative is the same as the slope of a tangent line, is defined and 0. Okay, so you can just see the tangents, we have horizontal tangents, and that's one way that we'll be able to find local mins and local maxes. Okay. So here, next we need to find a term, and we're going to define the word critical point. So critical point of f of x is a point C where C has to be in the domain of the function, the derivative is equal to 0, or the derivative is undefined. Okay, so to find the critical points, first you're going to take derivative. So next you're going to solve for where the derivative is equal to 0, and also find where the derivative is undefined. And those will be our critical values. Those are going to be x values. Okay. So we're now going to learn how we can find this theorem up here. Just tells us that if we have a closed interval and we have a continuous function, then you have to have an absolute max on that interval and an absolute min, and we're now going to talk about how to find it, and we'll use critical values. So here are our steps to find the absolute extrema. So the extrema just means both maxes and mins. So this is how we're going to find the absolute maximum and minimum on a finite closed interval. So you're first going to plug all critical values into the original function. So we just talked about how to find critical values. You're going to take the derivative, set it equal to 0, or find where it's undefined. You're going to plug those into your function. And then the other thing you have to do is plug the endpoints of the interval into the function. Now, whichever of those gives you the highest y value, that will be your absolute max. And whichever one gives you the lowest y value, that will be your min. Okay, so here it says find the absolute maximum and minimum values on the given intervals. So this only works when we have a finite interval like this. Okay, so first step, we need to find the critical values, critical points. So we're going to take the derivative, which here would be 7/8, and that's our only derivative. So here, 7/8 is never equal to 0. We actually, this is just a straight line. This is never equal to 0. We don't have any critical points. So we don't have anything there that we need to plug in. So we're just going to test the endpoints. And we always plug it back into, when we're finding the absolute maxes and mins, into the original function. So we're going to do f of -2 and f of 3. Now, this is quickest to do on our calculator, so I'm going to pause here for a minute. Okay, now the easiest way to do this with your calculator is to put your function into your y equals. And then we're just going to go to our table, and well, these values are easy enough, so we're just going to go up to -2, and we see that our y value is 3.25, and if we go down to 3, we see our y value is 7.625. So here, kind of our final answer, why don't I write my final answer in green, we'd say the absolute maximum is, I'm going to find the highest y value, 7.625 at x equals 3, and the absolute minimum is 3.25 at x equals -2. Okay. So now we want to do another one. This says f of x is x squared minus 3x plus 4 on the interval from 0 to 2. So first we need to find any critical points. So we're going to take the derivative of f, which here would be 2x minus 3, and we need to set that equal to 0. If we add 3 to both sides, divide by 2, we would get x equals 3 halves. Now 3 halves is in our interval, so we need to test 3 things now. And we also need to check, is there any place where the derivative is undefined? There's not. So we're going to do f of 0 and f of 2. We always do our 2 endpoints and our critical values. And again, we plug all of these in to the original function. So we're going to go to our y equals here and put in x squared minus 3x plus 4. Now one thing we can do, since 3 halves isn't an integer, isn't a whole number, I'm going to change my calculator. I'm going to hit second and I'm going to hit window to do table set. And I'm going to turn this independent auto over to ask. And I'm going to go over to the table, and now I can just put in 0 and it will tell me that this is 4. I can put in 2 and I'll get that this is 2. And I can put in 3 halves and it will tell me that this is 1.75. So here we can say, so here's our max, and here is our min. So we can say the absolute maximum is 4 at x equals 0, and the absolute minimum is 1.75 at x equals 3 halves. Okay, let's do one more. So we've got f of x equals 1 over x cubed on the interval from 1 to 2. So first, before we even take the derivative, I'm going to rewrite this as x to the -3. So the derivative is equal to -3x to the -4, which would be -3 over x to the 4th. Now, this is never equal to 0. If we tried setting this equal to 0, we could try multiplying both sides by x to the 4th, but then we would just get -3 equals 0, which isn't true. So it's never 0. Now, it is undefined at x equals 0, but the original function is undefined at x equals 0. So not a critical point since it's not in the domain anyways. So here, the only two things we need to plug in are the two endpoints. And if we plug in 1, we get 1 over 1 cubed, which is just 1. And we plug in 2, we get 1 over 2 cubed, or 1/8. So here we would say our absolute maximum is 1 at x equals 1, and our absolute minimum is 1/8 at x equals 2. Okay, so if you have a closed interval and you're asked for the max and min, you have to plug in the critical points and the endpoints, and you're plugging those back into the original function.